How's everybody doing this morning? Feeling okay after the party last night? I always feel like you can find out who the hardcore conference attendees are by looking at the first session of day 2, because those are the ones who are committed. They're the ones who, maybe you called it a night because you were being responsible, or you were out and you somehow managed to still get in here with coffee to power you through. I always find that impressive. I went out to dinner the other night, one of the first nights I got in here, just kind of by myself, went out and found a decent spot. And I was sitting there it was delicious, and they kept bringing out wine with each, different thing. I don't know anything about wine, so I just told the waiter to pick what he thought would be good, and it was okay. But it was the last course, and there was a couple across from me, and they brought out this dessert wine, and they brought it out to their table first and then to my table. And we sat through the entire night without saying a word to each other, but this wine got the guy in particular very, very excited. It was a very rich, sweet wine. I know, again, I can't describe it to you, just know that it was very sweet and desserty. And he was super excited about it, and so excited that he leaned in and he's like, "This wine is so good, isn't it?" And I was like, actually he said it in Danish first, and then I was like, "I'm sorry." But no, we started talking, apparently. I thought he was gonna get really depressed when he found out that I couldn't have an intelligent conversation about this subject matter with him, but he just went left field, and so he and his wife were talking to me about everything, about how I was enjoying, why I was over here, how I was enjoying it so far. It was only a few hours into it, so things were good. He told me, I believe it's Odin's, right? Odin's, the E is silent, kind of helped me with my pronunciation. They were just incredibly friendly, and it set the tone for this entire trip. I've never been to Denmark. I'm a little left field of this community, so I've not actually interacted with Umbracians, I don't know if that's the term, we're gonna run with it, before, but you all are a very friendly, fun-filled community. I love it. I'm a little nervous about the hammer and nails thing, but I'm gonna give that a shot at some point too. The first night I actually thought it was hatchets, so that was worse. But no, you're all very fun. And this is what I enjoy. I enjoy this so much. I enjoy traveling. I've always enjoyed traveling. I enjoy seeing new places, trying new foods, finding good coffee, and I enjoy meeting new people. I've always enjoyed that kind of thing. I do get nervous a little bit, but it's not when I'm there. I'm fine as soon as I get to the location. Even if I don't know the language, I feel like I can figure out enough from waypoints and stuff to find my way around, and people are generally friendly. I'm fine on the plane, but the getting there part freaks me out. I am a nervous traveler. So the night before, for example, much like the night before a morning talk, I will sleep horribly. I will wake up every 30 minutes to an hour worried that I'm going to miss and sleep through my alarm, or rather my alarms. This is an actual shot of my phone before a morning flight. I set 6 or 7 of these things staggered every few minutes. Is anybody, hopefully, somebody? Okay, good. I've never needed the 6th one. I've never needed the 3rd one, I don't think. But I can't sleep if they're not there. And you'll also notice, by the way, the times, they're 4:43, 40. Nothing is divisible by 5, and nothing is an even number. I don't know why, but when I set an alarm for something that's sensible, it feels really wrong. So I have to pick these random things. All I can say is that we all have issues we're trying to work through. This is one of mine. Someday there's going to be a psychologist who's going to have a field day figuring out all the things that are wrong with Tim. But no, this is what I worry about. I worry about waking up on time. I worry about remembering my passport. I check for that every 5 minutes on the way to the plane. I worry about making sure I've got everything packed. Tomorrow I'll worry about getting to the train and picking the right train and not going in the opposite direction, which I've done before. Those are the things that freak me out. But on the plane, I'm fine. At that point, the worst thing I have to worry about is wondering if the person in front of me is going to decide to recline their seat into my lap the entire duration of the flight. It's one of the few times where being tall is a definite disadvantage. But there was one time I got to experience what it was like to be a nervous flyer. I was flying from Minneapolis to San Francisco, so I don't know how much you know about the States, but it's a good journey. It's 4.5, 5-hour flight, but it's pretty fast for the distance. They're fairly on the opposite end of the country from each other. And it was a beautiful day. There, no weather issues or anything like that, and yet our flight was delayed. And in fact, it kept getting pushed back. One of those things where every time you look, it's coming later and later and later. And it didn't seem to make sense. If you looked at the board, nothing else was delayed. The plane was sitting there. The crew had arrived. Everything seemed okay. And as you would imagine, people were getting a little disgruntled about this. So somebody finally gets on the PA system to tell us what's going on. And they said, look, we're really sorry about the delays. There's a problem with the plane's engine, and we're looking for a temporary fix to get you to your destination. And yeah, most of you caught this, but I want to back it up for a second here and just replay that. There is a problem with the plane's engine. The thing that makes the plane move, that keeps it in the air, that thing's broken. And we're looking for a temporary fix. We're not going to solve the problem for you. We're going to find a temporary fix to get you 5 hours across the country. I'm all for providing feedback, but sometimes there is a thing as too much information, and I think we found it here. Now, I'm sure there were talented mechanics working on this at the moment, but I am not one of them. I am terrible when it comes to anything related to that, so I have no concept of what a temporary fix to an engine might look like. So I'm trying to translate that to something I understand, and I'm like, temporary fix, duct tape. Duct tape is a temporary fix. That's how I temporarily fix things. I don't want duct tape anywhere near my plane's engine. Now, this does have a good ending. We did get to San Francisco on that plane successfully. I didn't see any duct tape flying by, so whatever they did must have worked. But for that journey, I was freaking out almost the entire time. And I know for a lot of you, that's your day-to-day. Like on planes, some people just get really panicked about it. And frankly, it's understandable. Have you ever thought about the logistics of getting this giant metal tube to fly thousands of kilometers over countries, over oceans, at ridiculous speeds with hundreds of people in it, and keep it up in the air? It's something I don't recommend focusing on. Sometimes you really don't want to know how the sausage gets made, and this is one of them. But I am very grateful that not everyone overlooks this. I'm very grateful that there are professionals who pay attention to how this works and all the science behind it and the mechanics behind it, and know exactly what they need to do to make sure that if something goes wrong, there are fail-safes in place. That if some issue arises, that the plane is not just going to have some catastrophic failure. There are checks and balances in place, and they pay attention to this. They're the professionals, and we trust them to do their job, so we're able to just get on the plane and fly. For most people, when they use the web, there's a lot of complexity that gets abstracted away. It feels like you type in the URL, you press enter, and boom, the website appears on your screen, and it's done. It's almost magical. That's how it feels to most people. Now, you and I, we're the mechanics. We're the ones building these things, so we understand there's a lot more involved. It's not just type in a URL and boom, the site appears. It's type in the URL and, okay, which server across the entire globe do I need to talk about? Cool, I'm going to talk to that one. Let's figure out how we're going to do it securely. All right, let's set up a connection. Send me all the assets. You're looking for the HTML, the CSS. You find JavaScript, you have to stop everything and parse and execute and compile that and figure out what's going on. Once you finally have workable parsed HTML, CSS, and JavaScript, you can figure out what's going to be going where and how is it going to lay out, and then paints it out onto the screen. That's what goes on in that half a second that it took for the site to load up. There is so many steps, and there's so much of that we have zero control over whatsoever. You control the content that you're producing, you control the original code that you're sending out from the server. Everything after that is out of your hands. We're increasingly using CDNs, which we should, to deliver our content, which means that we're trusting them to do some delivery correctly, and there are issues every once in a while with CDNs. The network, we have no idea if the network's going to be high-speed cable, or if it's going to be some throttled Wi-Fi at a hotel, or if you're going to be working on some sort of a low data allocation mobile plan. Like, you have no idea what's going on from a network perspective. And the device, we have no idea. I mean, even if we include this device, like, we are sort of in a technical bubble, so we're likely to have a little less device diversity. But if we were to go around and have everybody kind of look at what devices we had, what phones we were carrying, I'm still imagining that there is quite a range here, right? So people could be using the latest high-end device. They could be using an Android device that they bought for $100. We have no idea. And when you think about all the variability and all the work that goes into getting the web to actually work, it's amazing that things actually work at all. We should not be surprised when that things go wrong. We should be surprised that the web works in any situation whatsoever. I think it's our job to anticipate failure. I'm available for motivational speaking, by the way. Our job is to anticipate this failure, because the harsh reality is that sometimes things are going to break. Something is going to go wrong. And one of our jobs as designers, as developers, is to expect that, to anticipate that, and to build in a way that makes sure that when it happens, the experience doesn't go completely haywire. And it's so dangerously easy to overlook. Again, we operate in a little bit of a bubble, so we tend to have pretty good networks, we tend to have pretty good devices. And so when we test our sites or applications on our networks and devices, things look really good, and then the user comes along and things don't work out quite as intended. The good news is that we are better equipped than ever. As intimidating as it sounds, we are better equipped than ever to build a more resilient web. We have better tools, we have better standards, we have better knowledge. We are better equipped to both understand the situation and to be able to account for all those different variables in our code and in our design. But the first thing to recognize is that we probably have a visibility issue. Has anybody ever sat through a performance talk before? Sat through sounds so negative. Has anybody ever enjoyed a performance talk? Well, that's a dangerous question too. Right, typically in a performance talk, one of the stats that almost certainly gets busted out is the average weight of a website. This is something that we've loved to show at every single performance talk ever since the dawn of time. Currently it's around 3 megabytes or so. But the average is a pretty questionable metric, right? It leaves a lot of information out. First of all, it's not even a data point from the data set, right? It's a representation of the data. It doesn't necessarily exist. But it's also very, very easy to sway one way or another. If you have 10 sites and 9 of them happen to be extremely fast and one of them very, very slow, the average is going to get skewed in one direction that is kind of misrepresenting the reality of what's happening. So generally, we've been moving away from using averages. Now, in fact, if you look at HTTP Archive, which catalogs performance data over the years, they present medians. Median looks much more optimistic, by the way. Now, median it's an actual data point, right? We're taking literally what's at the 50% here. But it still has a lot of the same issues. It still leaves off a lot of information that you don't really see. For example, if you look at the same data set, at the 50%, you have this 1.8 the talking doesn't get any better as we go. 1.8 megabytes, right? At the 90th percentile, it's 6.5 megabytes. There is a huge gap between the middle of the road website and what people are experiencing at these long tail of experiences. And so when we're looking at our own data, we need to be careful not to get too zeroed in on averages or medians or even just percentiles by themselves. We need to kind of take a long view. This is a graph from a speed curve from a client that I worked with last year. And what it's showing you here is the start render, that's the blue, compared to bounce rate, which is pink. And what you're seeing is as start render time gets longer and longer and longer, the bounce rate goes through the roof. There's a very clear connection here. Now the yellow line shows what the median value is. And at first they were kind of looking at this. And when you looked at the median value, it wasn't too bad. But we were curious about what was going on in this long tail, so we did some deep dive into the analytics. And what we found out is that most of those sessions were folks that were coming to the site on a web view, an embedded browser. It was a site that was heavily shared on social through Facebook, Twitter, etc. And those were pulling up in their own embedded browser instead of the default browser on the phone. And it turns out embedded browsers have a lot of performance constraints. Anything that is CPU intensive, any JavaScript work like that, significantly slower because that browser is competing with the parent app for resources. In this case, we often think of this long tail as these weird anomalies, but in this case it was the dominant use case, a dominant use case of the site that gets considerably slower experience and considerably less engagement. And if we were going to improve bounce rate, which was a primary goal of this project, where are we going to focus our attention? On those people, because that's where we have the most room for improvement. Again, we tend to look at the long tail as weird situations, but the long tail is where the real world happens. It's not anomalies. I like to think of it as a microscope. Every application ever built has weaknesses or bugs hiding about it, and it's not your fault, it's your peers who aren't here. I get it. But they're there anyway. They're lurking about in the code base, and it's easy for us to overlook. And by looking at those long-term, when we get those weak networks, when we get those underpowered devices, that's when we start to surface all of those underlying issues. It doesn't invent new issues. It helps us to make sure that we're not overlooking the ones that already exist. You know, in accessibility, they talk about situational disabilities. This is this idea that, you know, everybody has permanent disabilities. Often for many of us, it's going to be in a particular situation. You broke an arm, you're drunk, you're doing something that makes it harder for you to use the web today than it was for you to do yesterday. And I like this idea because it highlights that it's not accessibility for X group of people, it's accessibility for everyone, right? And it's the same sort of situation here. Again, going back to that use case, those web view traffic, if we looked back at those sessions, it wasn't the same people coming from web views every single time. It was the same people who occasionally get really fast experiences also were getting these obnoxiously slow experiences. It was everybody being impacted by this. It was situational performance. Focusing on improving performance for the long tail improves performance and reliability for everyone. I was able to do some work with MDN last year. Fantastic site. They already are very well built, pretty static at the time. Now they're kind of looking at some React stuff. And they had this massive global audience. But they wanted to see if they could push their performance a little bit further. Because they noticed in some areas they were having a little less engagement on the site than they would like. One of the things that really stood out that was weird was if you came to the site with a 1400 pixel screen resolution or less, you were far less likely to ever return to MDN than if you came with a screen size that was larger than 1400 pixels. It was, so somebody broke it down by resolution, and there was actually a very clear connection. It was 1366 pixel resolution. Those folks were far less engaged than a 1920 pixel resolution, which was the most dominant. Which was weird. We looked, they were twice as slow at that resolution, and we could not figure out why. There was no obvious reason. It was a responsive site, but there was no breakpoint that kicked in at that point. There were no assets that changed. Nothing got heavier. So we dug in a little bit more, and what one of the people on the team found is that 1366 is actually a very common resolution for those sort of entry-level laptop devices, you know, that you'd paid just a little, I'm not even gonna try to do the conversion, but very cheap, like go in, buy it off the shelf, affordable devices that are very underpowered. And so what they had found is they had a lot of people coming from these kind of devices, and for those people, they had a terrible experience and they just weren't coming back. And it was a huge clue because it tells us that the issue that we're having here has nothing to do with the network and everything to do with the device. We were CPU bound. In fact, if I profiled most of the sites in this room, I'm guessing CPU bound would be the commonality for most of them nowadays. It wasn't the case like 5 years ago. The network was the biggest bottleneck, but now it's the device. The device has gotten more powerful for sure, but we've also asked our sites to do more and more work. We've given them high resolution images, we throw a lot of JavaScript at it, we make them work harder than ever. And when you think about device constraints, you typically think about mobile devices. You think about things like the Alcatel One X. This is an Android Go phone you can get for about 100 euros. When it went on sale in the United States, it sold out on Amazon within hours and from the entire country within like a week. Massively popular, dirt cheap device. And I bought one just to see what it was like. I decided to use it for a week just to find out what the experience was. And I gotta say, it's awful. It's just terrible. It is. I do not recommend that anybody does this. It is a very painful experience. Although if you ever feel like you're kind of addicted to your device, this is the device to get for you because you will stop. You just, 2 days into it, I'm like, I'm not even gonna use Twitter or whatever. It is just a dumb phone at this point. And it's not that the phone is that bad. It's just that we've increasingly built a web that doesn't work on devices like that. Now in this case, of course, it wasn't a mobile device, it was a laptop. So whenever you probably have heard somebody say that you should get like some cheap Android device to test on, and I firmly believe that's a great idea, you should probably also just grab a cheap laptop. Go to Amazon or something like that, find the best sellers, and find the cheapest one, and get a copy of that and put it into your office or lab for you to test against. I feel like testing on low-end devices, it's one of the best testing tools that we have. We also have improved tooling outside of that, though. If you don't have access to the real device, we have tools for analysis for CPU issues that we didn't have before on the web. You know, people had that sort of on server, software development, but less so on any sort of front-end side of things. But that's changed. So webpagetest.org, which is a fantastic resource if nobody's ever used it, it's ridiculous that this site is free. It's an excellent performance testing tool. There's an undocumented feature. Pat should probably watch a couple of the documentation talks coming up today, but he admits openly that he hates documentation. But there's an undocumented feature called throttle CPU that you can pass in a query string. And what this will do is this will slow down the device that you're testing against by a factor of 3.6 in this case. Kind of a weird factor. I don't know why it chose that, but yeah. So now if you run the test on a laptop against a laptop device, it'll throttle that CPU so you can see what it's like if it's a little underpowered. Don't use this query string if you're testing on a mobile device. Those are real mobile phones. You don't need to throttle them anymore. But on a desktop device, it can be very powerful. We also have this built into DevTools. Chrome was the first to kind of roll something like this out, right in the DevTools where you can apply some CPU throttling. In this case, the presets are a 4-time throttle or a 6-time throttle. And then run a profile with the CPU throttled to that point to see what happens when you're not running this on the latest and greatest MacBook or the latest and greatest Windows machine. So we did this with Mozilla. We took and we fired this up on the 6x throttle and the 4x throttle to see what would happen. And we found out that for sure, like when the CPU was throttled, the site would come to a crawl. There was no JavaScript running. Like MDN is a very JavaScript light site. This wasn't the issue. In their case, it was the fonts. They used 6 different fonts. They used Zilla Slab, Bold and Italic, Open Sans, Italic, and Semi-Bold. And what was happening is each of these different fonts would sometimes arrive at different points in time in the page load process, depending on how quickly the network returned those responses. The way the browser works, when it gets a font, it has to do a whole new recalculation and layout to figure out, okay, I've got new text, it's gonna change how it looks, I gotta figure out where things are gonna sit. So I need to recalculate my styles, reapply layout, and it slows up the page again. Now it happens in this case, you see most of them coming together, that's most of these requests arriving at the same time, so you see one recalc and layout, which is not the worst thing in the world. But at other times, you'd see them come in little batches. And so you'd have 2 of them come here, and then you'd have this recalc and layout, and then 2 more and another recalc and layout, and then 2 more and another recalc and layout. So the page is constantly stopping along the way. So the fonts in this case ended up being the primary bottleneck from a CPU perspective, which is something I hadn't run into very often before. So we decided to see how we could reduce the number of fonts being used on the site. The first thing we tried to do is, how many of these do we actually need? The browsers have something called font synthesis. If they do not have an available font, so let's say that they have Open Sans, but not Open Sans Bold, they will try to fake it. They'll try to do font synthesis and figure out what a bold might look like by changing a few things. So we set up a page with 4 different iframes, showing the regular versions loaded by themselves in one iframe, and letting the browser do font synthesis, and then doing all 3 variants in the other iframes. And then we loaded these up very quickly, just a very well-designed page, as you can see, but very simple little page that we could load up in a ton of devices very quickly to see what was happening. And there was a few things that stood out. First off, we were pretty comfortable with the font synthesis from the italic perspective. Some of you who are type enthusiasts might want to throw something at me after this, I understand. But we put this in front of most people and couldn't tell too much of a difference. So we were okay with the italics. The bold versions are pretty much awful. The browsers do a terrible job of bold font synthesis. I assume it's because they're trying to be very conservative about it. Chrome in particular has almost no noticeable difference between their bold font synthesis and like a regular font. So we weren't okay removing the bolds. But based on this experiment, we could say, all right, let's cut out italics for both of these. Now we get it down to 4 files. Then we were looking at, could we maybe fall back to a system font entirely for one of these? Zilla Slab is the branding font. It is the font that goes into the headlines, the logos. It is Mozilla's brand. We can't kill that one. But we were a little less convinced about Open Sans. So we used a tool built by Monica Form. I think she's still at Google and just in a different group. She built this tool called Font Style Matcher, which is fantastic. It's actually geeky fun to play with, too. What it lets you do is it lets you pull up a web font and a fallback font side by side. You can tweak all the CSS settings like line height and letter spacing and things like that. And my favorite part is at the bottom, as you're doing this in real time, it'll show the same text in these 2 different fonts overlapped. So you can see exactly what the differences are. So you can play with things until you get to a point where you're like, these look really similar. These have a very similar feel to them. You're typically using something like this to figure out what your fallback is. So you can declare, Open Sans with my fallback being like Verdana or something like that. But in our case, we were using it to find something that was a close replacement. And what we found is that Verdana, if we played with a few settings, was almost impossible to tell the difference. Here's a side-by-side of Open Sans and one of them and Verdana and the other. It's pretty tricky for most people, for most of the copy, to be able to tell. So we put this in front of a bunch of people. Nobody realized that we did anything. So we're like, all right, Open Sans is out. We'll just use Verdana. So now we had it down to the 2 font files. Now just one disclaimer on that. We walked back on it a little bit. We were cool with Verdana. Verdana Bold is kind of funky. We weren't cool with Verdana Bold, so we ended up, I think they're using Arial now at this point. So all that font style matcher worked for nothing, but it was a cool process. But we got it down to these 2 files. The last thing to do is make the files as small as possible so that they arrived as quickly as possible without stopping the page later on for the recalc and layout. By default, they were 67 kilobytes each, so we did some subsetting. Basically, each font file is made up of hundreds and thousands of different glyphs depending on the languages you support. So you can pull out the different characters that you're not going to use, get those out of the file entirely. For that, we use something called pift subset. What it let us do is it let us put a little file together where we defined the different Unicode ranges of the fonts that or the characters we wanted to include. So here you can see exactly what we pulled into the bundle. Now with one command, we're able to do pift subset, pass it the original font file, pass it the file full of all those Unicode values, and then tell it the flavor to spit it out. Flavor, the little personality behind it. But spit it out, in this case, is WAF2, which is the latest and greatest highly compressed font format. And we could run this as part of the build process. And if we ever needed to add more characters, we could just update the Unicode file and nothing about the build process had to change. It worked great. I would say that if you're from a developer ergonomic perspective, one thing we did not exist when we had started this work that does now, you might prefer Glyphhanger. It's a node-based tool from the Filament group, and it's much more friendly from a developer perspective. The documentation's better. It also does some really cool things, like you can actually pass it URLs or page templates, and it'll figure out what text is used on that page and just subset to that. So it's a pretty fun, I think in retrospect, we probably would have looked at this. But after we did this, we got each of the files down to 33. So we basically cut our font weight in half at the end. So looking back at all that work, every user got about 300 kilobytes less weight by doing all this font work. We saw folks on sort of the middle tier device, which we defined as that sort of 3x, 4x throttle. We saw them get 12% less time spent on layout during the page process. And the primary goal for MDN on any page is to get you that interactive example. If you've ever used MDN, there's often these examples that you're able to play with the code and see how it works. Their primary goal is to get that down as quickly as possible. And so for the folks that had the sort of the low-end experience, the folks we had set out to help in the first place, they got about a 1 second faster time to interactive example. So everybody across the board got a better experience. Most people got better speed, and everybody got less data. I worry a little bit that we've forgotten about the data aspect. Over the last few years, performance has kind of undergone this renaissance where we've sort of pushed more towards user-centric metrics. So we've moved away from things like load time, and we're trying to find things like timed interactive or time to first meaningful paint, like things that are more focused on the user journey. And I feel like in the process, we've sort of ignored data a little bit, which is too bad because data is a very user-centric metric. For years, millions of people have been using tools like UC Browser or Opera Mini to try and proxy because they don't want to use as much data, because that's how they have to access the web. And often it's a very mundane situation. Like often it's just people who are sitting on a limited data plan and they have a low budget. My favorite site to pick on for this is the Facebook Instant Articles site, because when they came out, they were like, the mobile web's too slow, so here use Facebook Instant Articles. Meanwhile, their site was like 80 megabytes on a mobile device, so it was kind of ironic. But if you tested this and checked to see the weight versus the cost of data around the world based on information from the ITU, what you found is that in many places, when you adjusted for purchasing power, it exceeded the daily poverty limit to load this one single page. Like, it was costing up to $1.44 here in the States, above the poverty limit, just to load the home page of the Facebook Instant Articles site. In some countries, that meant up to 10% of the per person daily income was being spent on a single URL. So the costs can be a little bit ridiculous. You know, the stakes can get a little bit higher too. There was this report maybe a year or two ago about refugees and how they were trying to choose between, in many cases, do we have access to data or do we talk to our families? And they were spending as much as 33% of their disposable income trying to keep this data so they could keep in touch with people so they could get the news and information that they needed access to. Or in the situation of when the Hurricane Florence tore through the United States, left many people stranded in need of food, in need of other supplies. They desperately needed information too about recovery efforts, and where to go to get this stuff. Now, if they want this information from any sort of online source, you have to tread very, very carefully because power is wiped out. So you have to monitor that battery level. And again, if you're on any sort of data constrained plan as well, or even if you're not on a data constrained plan, just the sheer amount of congestion, the amount of people obviously trying to get onto those networks to get that information is going to bring everything to a crawl. So performance becomes paramount. At least one site recognized this. NPR put out a tweet around the time that said, hey, we've got a text-only version of the site for anyone who needs to stay up to date on news and keep their battery and data usage to a minimum. Now, you're maybe familiar with this. Is actually the same site. If you go to NPR and in a post-GDPR world and say that you don't want cookies, this is the same site you get. You get this. You get this text-based version, quite literally text-based. There's no images, it's just the news stories, there's no CSS, there's no JavaScript, there's nothing. As you would expect from a page that is nothing but HTML, it's tiny, it's like 1 kilobyte, it has no impact on your data and no impact on your device at all. Now, I'm not saying that we should all do this, like that we all need a text-only version of the site. I'm also, if you did do a text-only version, I feel like you could spend 1 kilobyte more to put a little bit of branding on it. Like, it doesn't have to look like this. It's okay if it's 2 kilobytes. But no, I'm not saying that we all have to do this. I'm certainly not trying to say that we all are going to have stakes that are this high, right? It would be very disingenuous of me to imply that in any way. But I also think that it wouldn't be that bad of an idea if we sort of tried to look at our content this way and tried to prioritize the experience when things go completely haywire. And again, it's usually not things like this. Usually it's more mundane situations, but those mundane situations still have a measurable impact on people. There was a survey done a few years ago where they asked people how they responded to slow mobile sites, and what they got, the results were kind of entertaining. 11% of people said that they yell at their phone when something is too slow. Has anybody yelled at their phone? Okay. 23% of people swear. I'm curious where the discrepancy is between these two numbers, by the way. Like, they feel like they should be closer, but okay. 11% yell, 23% swear. The fun one, 4% throw their phones when their sites are too slow. There's one person who's thrown the phone. I don't want to criticize anger management things or anything. Maybe those folks are preparing for the mobile phone throwing world championships, which is apparently a thing in Finland. I didn't know this. This is kind of fun. Look how early they start the training too. They get you off to a start early on. No, so anger management issues aside, there's science to back people's response to the survey as well. There was a study done where they hooked up EEGs to people's heads, brains to see, monitor brainwave activity, see what was going on when people are using a slightly slower experience. And what they did is they gave people either a 5 megabit per second connection or a 2 megabit per second connection. 5 versus 2, it's not a huge difference, right? It's this marginal amount. And yet they were still able to see measurable impact. The people that were using the 2 megabit per second connection to do these same routine tasks were significantly more stressed out and had to put about 50% more effort into concentrating to complete those tasks than the folks who had a slightly faster experience. So even in mundane situations, performance can have an actual physical impact. And the thing is, it doesn't have to be this way. I can't think of a single example from any company that I've ever worked with, any company that I've ever profiled, where we couldn't make the core experience of the site faster. It's all these embellishments and stuff that get in the way. There was a talk years ago from The Guardian, and I always loved the way that they broke it down. They had this very layered approach to how they viewed the content and delivery of their site. They broke it down into 3 sections. They had this core content. This was your being able to read the story, having the essential HTML, some CSS, and a usable non-JavaScript driven experience. We'll come back to the non-JavaScript part in a bit. But they had this core experience. That was their first priority. Then they had this layer they called the enhancements. That's where JavaScript kicks in. That's where they get the enhanced CSS, their fonts, their images, little widgets that people might find useful. And then finally they had the leftovers, which was the analytics, advertising, third-party content, the things that the users probably don't care about, although your business might argue against the leftovers, category here. But they broke it down in these 3 different layers. And the idea being that with this layered approach, they were going to build each layer in a defensive way so that if something further down happened that failed, the core content stood alone. So if your enhancements didn't kick in or didn't work for some reason, you still had a usable site. If the enhancements kicked in, but something went wrong with one of the third parties, you still had a usable experience. They were building defensively all the way through. The BBC does a fantastic job of this. This is the BBC site with and without JavaScript. Notably, this is also the BBC site from the United States. They don't do ads, apparently, I found out in the UK on the BBC. So that was a fun example. Somebody pulled me aside after a talk in the UK and pointed that out. But no, so the only difference from a US perspective is the ad, basically, and a little bit about the navigation. But the site looks very branded, it's fully functional, the content's all there. There's almost no perceptible difference between the two. Something could completely go haywire in their JavaScript stack and the user would never know. Now, many of you are probably thinking, no JavaScript, that's not a thing, people don't really disable JavaScript. I kind of agree. Every study we've ever seen shows that it's maybe 1 to 2% of users intentionally disabling JavaScript. It is a tiny fraction. Now that being said, the no JavaScript experience probably impacts more people than you think. Ian Feather from BuzzFeed got on stage at a few conferences the other year and talked about how they see 13 million requests a month for JavaScript that will time out. 13 million requests a month, and this is BuzzFeed. This isn't like a small company. They have all the resources. They can afford all the CDNs. They can afford the brightest and best tools and engineers. And they're still seeing this many requests for JavaScript just fail every single month. Things happen. CDNs go down for a minute or two, and that can cause a huge crash in your JavaScript just over even if you get any sort of significant traffic at all. Mobile operators tend to be helpful. There was this thing where T-Mobile years ago decided that they were going to try to compress sites that were coming down by looking for any comments in JavaScript and stripping them out. Well, it turned out that there was a pattern in jQuery that looked like a comment, so they stripped, and then they could never find the end comment, so they ended up pulling out 90% of jQuery for every site that was coming down over the network for a few days. That kind of thing happens, helpful mobile operators. Or as Jake Archibald, who's at Google now, loves to say, everybody is a non-JavaScript user until it actually downloads and gets executed. Right? There's all sorts of situations where the JavaScript might kick in. And Chrome gave us another one. Chrome has introduced this concept of interventions. Back in August, somebody discovered, Google hadn't announced it, somebody discovered in a commit log somewhere that Chrome was going to start looking at disabling JavaScript on slow connections. And it caused some significant heat, as you might imagine. We get a little attached to our JavaScript at times. But you can't argue with the results. I fired up 10 different news sites at the time just to see what the impact was. And for most of them, massive improvements. BBC was marginal, 24%. You saw they weren't losing much. These other sites were all usable, but for most of them, it ranged from 70 to 90, 96% reduction in data just by turning off JavaScript. Now, there are 2 huge anomalies here, right? The Atlantic and The Verge, which got 290 and somehow 2,000% slower. I was super curious, so in case you are, the reason why is if you looked, they used JavaScript to do lazy loading of images. So they had a pattern like this, where they had a div that would reference the image, the JavaScript would kick in and pull that image in, and they were smart and responsible, and they did this no script fallback. So if JavaScript was turned off, you got this fallback image. But the fallback images were uncompressed, so they ranged from anywhere from 2 megabytes to 10 megabytes per image to pull these in. But it was a simple fix. The Atlantic fixed it, I think, like within a day of my post coming out. I think The Verge fixed it at some point. I haven't gone back just to double check, but I hope so. But it was a relatively quick fix. But I think it is fair to be a little concerned about this, right? Because not everybody fares this well. If you're heavily reliant on JavaScript on the front end for your site, you're going to have some issues if things go haywire. This is Engadget with that optimization applied. There's not much to it when JavaScript is gone. Now, I want to be clear here. My message is not to don't use JavaScript. I just feel like we have to use it responsibly. I find it really fascinating that in the last few years, JavaScript has infiltrated every part of the stack. We have JavaScript-driven build tools. We can run JavaScript on the server. We can even put JavaScript on the CDN now. Cloudflare has this whole Cloudflare workers where you have a proxy that's programmable with JavaScript on the CDN. JavaScript is everywhere, and yet we keep insisting on putting more and more of it on the one part of the stack that is the least equipped to deal with it, which is the client. In general, the less the work the client has to do, the better. The better the performance and the better the resilience. Now, it's not just JavaScript. We already mentioned fonts and how they could have an impact. We touched a little bit on images. And it turns out that JavaScript is certainly not the only thing that Chrome is looking at intervening on when it comes to your sites. They had documented, if you looked inside their platform status, they had documented the first 4 major interventions that were going to be a part of what they call light pages, or light mode. In Chrome, there's a data saver button. I don't know if you've ever seen it, but if you can toggle it on, it says, hey, I would like to use less data. So in a situation where folks have opted into this, and it's a slower network, they have these 4 different interventions they'll apply. Disabling JavaScript entirely, which we already talked about. Replacing images with placeholder images, although that one sounds like it might be on the way out. They're constantly kind of changing these up. It's very quick-paced. And stop loading non-critical resources. So if it's a resource they deem as non-critical to the display of the page, just not cutting that out entirely. As well as showing offline copies. So if you've gone to the site before and they feel like they have a probably pretty good cache page, they'll show that one to you instead and give you the option of pulling in the major one. All of these tend to be really good from a user perspective, from a performance perspective. They all have some, issues as a developer. You have to make sure you're using your images responsibly. Even the cache pages can sometimes look a little broken. But before you panic, it's worth noting that these are interventions, which means that Chrome doesn't want to do this. Nobody wants to do an intervention. It's something that you feel like you have to do when things are getting really bad. And that's what's happening here. So if you perform well already, then you're probably not going to have these interventions applied. It is one of the heuristics that they look at, is how well does the site perform, as well as how does the site perform when the user has indicated they want less data used. When they use that data saver mode, or when anybody's using Opera or any other sort of proxy service, there's a save data header that gets passed along that just says save data on. I don't typically get excited about HTTP headers. It's not my cup of tea, but this one I'm pretty jazzed about. And it's not because of what it does. It does nothing by itself, but because of what it signifies. Think about all the millions of euros or so much money has been spent on surveys and things trying to figure out what does the user want from us? What can we do to give them a better experience? And here they are telling us up front, right away, I want to use your site, I just want less data. They are telling us directly what to do to keep them around. And I think that's extremely unique. And I was so excited about this. I was like, I'm going to query the top 500 sites and I'm going to find out what they're doing and give some cool examples. And no one is doing anything. There's nothing happening when the save data header is applied. Like nobody is doing any significant, meaningful changes at the moment. And it wouldn't be too difficult. We could be creative and kind of take control of this situation. You can detect it either on the server and serve something up entirely different, or you can detect it on the client in JavaScript. You can look for the headers and look for the presence of that saved data header. It's also available in the navigator.connection API. But in either case, you just look for the signal and you're able to adjust the display of your content in some sort of a way. Disable web fonts, remove a few images, do something to shrink that data down a little bit. Most people probably aren't even tracking this. I've talked to very few companies who are paying attention whatsoever to if this is coming through. It is new, and it's understandable. But I did get one company, and I wish I could reveal their name, but I can't. But it's a large global travel organization. A large global travel organization that gets about 6 million daily users 20% of those users have the Save Data header enabled, it turns out. 20%, which is significantly higher than anything I would have pegged it at. That's, to put that in perspective, I'm pretty sure if you go and look at your analytics, that's probably more than every browser not named Chrome and Safari combined. Like, that is a huge percentage. And again, it doesn't have to be something where you have to completely gut your site over this. Here's an example of what we could have done on the BBC. This is the BBC homepage. What we could have done if the Save Data header was present is just pull out some of those thumbnails. This reduces it by about 300 kilobytes of data, and the branding is maintained. It doesn't look broken. It doesn't look wrong in any way, shape, or form. It just uses a little less of the user data. We can also pull this information into a service worker. I think last year there was a talk about a service worker here. I don't know how many caught that. But a service worker is this programmable JavaScript proxy in the browser where you can manipulate requests. So any request that goes out, the service worker can alter. So here's an example where we're checking for saved data, and if saved data is there, at the top, we're going to return like a really highly compressed image. And in the bottom example here, if we're requesting out for Google Fonts, what we're going to say is, you know what, we're just not going to load web fonts because people have asked for us to use less data. We're going to use our fallback. You know, service workers are an incredibly powerful tool for combating like issues around network stability and poor connectivity. And we often think of that as like these rural areas. I think we gloss over that this impacts urban areas just as much. Katie Hempenius from Google had tweeted out a while back, she was measuring latency traveling from Washington, D.C. to New York City, and if you've not been to that area, that is not rural America. That is like big city after big city after big city, and she's seeing this discrepancy between 150 milliseconds of lag to 3 seconds to complete a connection over these different networks. Amazingly inconsistent. This was my home internet for months before finally we got a new provider. I'm from a small town of 1,200 people, so I kind of get it too. Before we got a new provider, but for months this was like peak for me. It was like getting this 2.8 megabytes was amazing. And there was a recent study done in the UK that showed in some like areas, some rural areas where we were seeing at peak 0.26 megabit per second connection. Again, in like remote areas of Southeast London. So this is a lot of these urban areas can be impacted just as badly because of network congestion or other issues. And service workers help to defend this. Service workers, it's their own talk, it's their own workshop, but conceptually here's what's happening. The browser has a few different caches that it can look in for different resources. So the first thing it does when it looks for an image is it says, cool, do I have it in the memory cache? Meaning, is it around on this page view? If so, I'll just pull it from that. If it's not, like probably a new page, then it's going to go out to the network stack and check what's called the disk cache. So this is where things that get cached for a couple days or weeks or months are stored into this cache. And if it doesn't find it in the disk cache, it finally will go out to the network and say, okay, cool, I'm going to need to request this asset. What a service worker does is it introduces this whole new step in the process. So it first checks the in-page memory, the memory cache, but then before it ever goes out to anything related to the network, it checks the service worker cache. So if you have an asset that you've pulled down by the service worker, it never goes out, never even bothers checking with the net stack, which means that you can alter any request before it ever hits the network. You can do all sorts of stuff with this. That's why you have offline support, because it doesn't need network support at all. You could do things where you're racing resources to different CDNs to see which one comes back faster and using that. You could do your own custom timeouts. You could say, all right, cool, you're requesting this image. I have a cache version, but if I can get a new version in the next like 2 seconds, I'll return that instead. You can do whatever. You could swap all your images for cat GIFs. You could do whatever you wanted to from a service worker. It's just incredibly powerful. And this is what I mean when I say that we're better equipped than ever to do this. We have better tools. We have better knowledge to be able to provide these good experiences to the long tail, to everyday users. You know, pick up a cheap Android device, pick up a cheap laptop device, and test on those. And if you don't have access to those, you can use the throttling built into browser dev tools or web page tests to sort of simulate that experience as well. You know, if we're careful about taking this layered approach to our site and prioritizing our critical content and our core experience over all the different enhancements, there are many opportunities to build resilience into the site itself. Careful planning of those font fallbacks or situations where CSS or JavaScript or images don't come in help to account for a lot of those issues. Technologies like service workers help to provide this sort of buffer layer in between so we can be proactive about this. Users and browsers both have been trying for years to find ways to make the web more performant. Users have been using browser technology and proxy technologies. We have browsers that are rolling their own proxy services and interventions and stuff out. They're trying to find ways to make the site faster. And the better we do it ourselves, the more control we have over it. The more we get to retain our branding without worrying about whether or not this service is going to break it on us. We don't control how people experience our site. One way or another, we still get judged by how that experience turns out. So we have a choice. We, the mechanics, the professionals, the people who are building these things, we either get to let the users fend for themselves when something goes wrong, or we can be proactive about delivering an experience that works even when something goes haywire, and it performs well even if the network is throttled, even if the device is underpowered. When the inevitable happens, they still have a usable experience. The choice is ours. Thank you.